Hey everyone, Math 106, Section 5.1. In this course, we're learning real-world math, and that means working with numbers with units. So we're going to learn some of the most powerful and important techniques for working with numbers with units. We're starting off today, since we're going to be doing so much multiplying of fractions, a little refresher. So multiplying fractions, we're going to multiply straight across, numerator by numerator, or top by top. A times C gives us A times C in the product. And then we'll multiply denominator by denominator, bottom by bottom, so B times D gives us BD in the denominator. So let's practice that with some real numbers. So example 1, we're multiplying straight across. 2 times 3 gives us 6, and 7 times 5 is 35. 6/35. And that fraction is already reduced, so that's the final answer. Your turn, number 1. Just a reminder, I don't stop before the your turn, so while you're working on them, just pause the video and come on back. Multiplying straight across here, we get 8 on top and 55 on the bottom. 8/55. Now some fractions, there's an opportunity to simplify before we multiply. Now we can always just multiply straight across, then simplify the fraction. But we can simplify it beforehand, and that makes things easier. And this will be a better introduction to what we're going to be doing. So when you see a match on top and the bottom, same number, we're going to cross those out, those cancel. And when you cancel numbers, they turn into ones. So now we've got 1 times 5 on top and 9 times 1 on the bottom. So that one is 5/9, and that is fully simplified. Your turn, number 2. Now here, notice we have some matching 3's. So those cancel, turning into 1. Multiplying straight across, 1 times 7 is 7. 5 times 1 is 5. 7/5. This technique extends to any number of fractions. So in example 3, we can look for any pairs of numbers that are the same and cancel them out. So we got a 7 here and a 7 here, those cancel. And a 5 and a 5, those cancel. Now all those numbers turn into 1s. And now all we have left to do is multiply straight across. 1 times 1 times 2 gives us 2. 1 times 9 times 1 gives us 9. 2 9s. Your turn, number 3. Elevens cancel, and the matching 3's cancel. All those numbers turn into 1s. Now we multiply across. 1 times 4 times 1 is 4. 1 times 1 times 7. 4 7s. Now in order to divide fractions, we need the idea of the reciprocal. The reciprocal of any fraction is that fraction flipped over. The numerator becomes the denominator, and the denominator becomes the numerator. So what we're going to do, whenever we're dividing fractions, we are going to convert to multiplication first. So if I have A over B divided by C over D, we're going to convert that to multiplication. Division turns into multiplication, and the second fraction turns into its reciprocal. And that's how you convert division into multiplication. And then just multiply straight across, just like we did before. A times D gives us AD, B times C gives us BC. Example 5. 2 over 9, convert to multiplication. Flip the second fraction over. Biggest mistake I see is people flipping the first fraction over. Don't flip that one stays exactly the same. Now we'll multiply straight across. 2 times 5 gives us 10. 9 times 7 is 63. Your turn, number 5. Convert to multiplication first. First fraction stays the same. Division turns into multiplication. Second fraction turns into its reciprocal. Multiplying that out, we get 8 on top, 21 on the bottom. 8 21st. Example 6. Convert to multiplication. Now we can do what we did before. Look for opportunities to cancel. Got a 5 on top, 5 on the bottom. Those are going to cancel out. Turning into 1s. Finally multiply straight across. 3 times 1 is 3. 1 times 8 is 8. So 3 eighths. Your turn, number 6. We convert to multiplication. That turns into 3 sevenths times 7 fifths. Now the 7s are going to cancel, turning into 1s. Now I got 3 times 1 on top, 1 times 5 on the bottom, 3 fifths. So you may be used to math classes where you just work with a bunch of numbers, there's no units, so you just get an answer, x equals 2. All right. Well, what is x? I don't know, it's 2. We're working with real world math, so we're always going to have the units in our answers, so our answers are going to have meaning. And most of the numbers we're going to be working with, they're called measurement numbers. They're obtained through direct measurement. Now, certain operations we can do with units with, or numbers with certain units. So let's look at addition and subtraction. What do we get when you take 3 cars plus 2 basketballs? Well, 3 cars plus 2 basketballs. You can't simplify that. You can't simplify it into 5 basket cars or something like that. It doesn't work that way. So the only things that can be added or subtracted together are things that have the exact same units. So example 7. Got 3.47 feet plus 2.3 feet plus 0.09 feet. All right, they all have the same units, so they can be added together. So we add them up and we get 5.86. All right, we're adding together the numbers to get 5.86. And the things we're adding together stay exactly the same. Don't change the units when we're adding or subtracting. And if we have 3 cars plus 5 cars, we get 8 cars. We don't get 8 something else. So the units stay the same. They don't turn into feet squared or feet cubed or anything like that. They just say feet. Your turn, number 7. $375.4 meters minus 369.1 meters. Subtract that. Subtracting the numbers, we get 13.5, and the units stay the same, 13.5 meters. All right, now we're going to go on to multiplication and division with units. Now with multiplication and division, anything can be multiplied, anything can be divided. It doesn't matter what the units are. However, what the units are will affect the units we get in our answer, and certain types of units interact differently. So example 8, we're going to multiply 2 numbers with the same units. 1.9 meters times 2.7 meters. Now when multiplying, the units will change in the answer, unlike addition and subtraction where we got the exact same units. So we're going to multiply the numbers, 1.9 times 2.7. That gives us 5.13. Now to see what the units become, let's think of this as being lengths. So I got 1.9 meters here and 2.7 meters here. If we multiply them out, we go from 1 dimension where we have length to 2 dimensions where we have area. So basically what we're doing is we're taking meters and we're multiplying by meters. Now if we had variables, x times x, we get x squared. Or 3 times 3, we get 3 squared. Well with here, meters times meters, you guessed it, meters squared. So 5.13 meters squared. So if we multiply two quantities with the same units, our result has those units squared. Your turn, number 8. .085 feet times 7.47 feet times 3.4 feet. Multiply the numbers together first. And we get 21.5883. Not worried about significant digits, just multiply them out. And now we're going to multiply the units together. Feet times feet times feet. Well, if we do 2 times 2 times 2, that's 2 to the third power. X times x times x is x to the third power. So feet times feet times feet is feet to the third power, or feet cubed. Now there's another symbol we can use to write this. We could have wrote this as 5.13 square meters. That's the same as meters squared. And over here we could write this as 21.5883 cubic feet. Anything to the third power is cubed. So cubic feet. And so we've gone from one dimension, multiply them out 3 ways, and we get 3 dimensions. Now some units of measurement are combinations of other units. There's different names for these. Some people call them derived units or compound units. The units comprised of more basic units. So we take a couple of simple units and combine them together into something more complex, like a rate. Example 9. We got 1.8 kilometers divided by 3 minutes. All right, now we divide this out. Another way of writing it, 1.8 kilometers divided by 3 minutes. The division bar, if you want to say this in words, can be read as the word per. So what we really have here is a rate, kilometers per minute. So we'll divide the numbers. 1.8 divided by 3 gives us 0.6. Now we have the derived unit, or the compound unit, kilometers per minute. Or you could write it as 0.6 kilometers per minute. Your turn, number 9. So we're going to take 225 miles divided by 5 hours. So 225 divided by 5 is 45. Miles per hour. All right, miles per hour. Or the common abbreviation MTH, 45 miles per hour. All right, so now we're going to combine together the skills of fraction arithmetic with units. So we're multiplying fractions with units. If identical units occur on the top of the bottom, we're going to cancel those out. Just like we did when we were multiplying fractions, we had the same number on top, same number on the bottom, and canceled those out. We're going to do that with units. And then look for any opportunities to cancel matching numbers as well. All right. And then we're going to multiply straight across the numerators. Just like we did with these operations, multiplying units, we're going to multiply straight across. Simplify the result. And now, any units that are left over after canceling units are the units with the answer. So let's look at example 10. Now with these first few problems, all the numbers are going to be 1. So spoiler alert, the answer is 1, numerically. The question is what units are we going to have. So let's pay attention to the unit signs. All right, 1 meter over 1 times 1 second over 1 meter. All right, so multiplying now. Let's look for opportunities to cancel. We have meters on top and meters on bottom. So those units are going to cancel. Meters and meters. They're gone. So what units do we have left? Just S for seconds. All right, so multiplying straight across, we get 1 on top, second over 1, which is just 1 second. Sometimes it's hard to tell what these are when they're all abbreviated, but 1 second. All right, your turn, number 10. One ounce per kilometer times 1 kilometer over 1. All right, the matching units are kilometers. Kilometers cancel. What are we left with? Just ounces on top. So 1 ounce over 1. So the answer is 1 ounce. Now units can end up in the denominator. Example 11, we got 1 milliliter over 1 kilogram times 1 over 1 milliliter. And if you don't recognize these abbreviations, these units, we're going to do a unit on the metric system coming up, so they'll become more familiar then. All right, milliliters on top, milliliters on the bottom, milliliters cancel. Now multiplying straight across. Got no units left on top, so that's just a 1. Multiplying straight across, 1 kilogram times 1 is 1 kilogram. So 1 over 1 kilogram. Yeah, I'll put 1 in there. Good. Your turn, number 11. Matching units, minutes on top, minutes on bottom, those cancel, leaving us with just 1 times 1 on top and 1 times 1 foot on the bottom, so 1 foot. 1 over 1 foot. Now sometimes we're going to end up with units on top and the bottom, And that's what's known as a rate. Some common rates, just like we saw here, miles per hour, gallons per minute, things like that. So you got 1 meter divided by 1 second times 1 second over 1 liter. And the seconds cancel. Those are matching units. Nothing else matches. We're not going to cancel anything else. And the result then, 1 meter times 1. And 1 times 1 liter. So 1 liter on the bottom. So we got 1 meter per liter. Your turn, number 12. One kilogram per minute times 1 minute per centimeter. Matching units are minutes. Those cancel. All right, now multiplying straight across, we got 1 times 1 kilogram, so that's 1 kilogram. And 1 times 1 centimeter, 1 centimeter. So 1 kilogram per centimeter. Now that may seem like a very strange unit, but it may have meaning in the real world. It could be the weight of a steel bar. Every centimeter adds another kilogram to the weight. Now we're going to look at some units that are raised to a power. Think about what that means. Well, it means we have 2 of them multiplied together. All right. So the first one, 1 foot squared is 1 foot times foot. So we have 1 foot squared divided by 1 kilogram times 1 kilogram over 1 foot. Now this is 2 feet multiplied together. So this is 1 feet times feet over kilograms, 1 kilogram. So there's a couple of different ways we can solve this one. If we want to do this, we can just cancel 1 of the feet and this foot, leaving this one, and kilograms cancel. So what do we have left? We got 1 feet on top times 1. All the units have canceled in the bottom, so 1 times 1 is 1, so that's just 1 foot. Now you don't actually have to write it out like that as feet times feet. What is often done is, since we have exponent of 2, that means 2 of them, we're just going to get rid of the exponent and cancel that with feet. And then we're down to 1 foot, just like we did here, just like we had there. So those 2 things are equivalent. You can solve those either way you'd like. Your turn, number 13. We have matching meters, cancel those. We have 2 seconds on top. We're going to get rid of 1 of those, leaving just this one, and get rid of that one. So that gives us 1 second over 1, which is just 1 second. All right, so we're done warming up. Now let's look at some more realistic ones with some numbers other than 1. Example 14. $18.7 meters over 3 seconds times 2 seconds over 1.9 liters. So let's start by canceling the units. We've got matching units on top, seconds here, seconds here. Those are gone. What units are we going to have in our answer? We're going to have meters over liters. All right, now we're going to multiply, just like we did with the fraction, multiply straight across numerators. So we get 37.4 on top. And we get 3 times 1.9. It's 5.7 on the bottom. And the units then, we're down to meters on top and liters on the bottom. Now finally we'll divide those numbers, 37.4 divided by 5.7. Once you get down to a single number on top, single number on the bottom, then we can divide. I'm gonna misprint on my sheet here, just give me 1 second. All right, so that gives us 6. And then we keep the units, meters divided by liters. Your turn, number 14. Round to this one, the nearest whole number. Usually we're going to round to the nearest 10th. All right, so for this one, let's see what we got here. We got gallons on top, gallons on the bottom. So those cancel. And now we're going to multiply straight across. Got 137.4 times 8.6. That gives us 1 and 1. 81.64. On top, then we're going to multiply by the bottom, 2.4 times 6.8. That gives us 16.32. Now the units we have left, we got pounds on top, seconds on the bottom. Now finally we can divide these numbers, and we get 72.4. Units being pounds per second. So we divide like this, 48 meters divided by 4 seconds. We'll just keep both of these units in the answer. We'll divide the numbers out. 48 divided by 4 gives us 12. And units, meters per second. Your turn, number 15. So we got 744 megabytes divided by 12 seconds. Divide those numbers out, you get 62 megabytes per second. Now next we're going to divide by a rate. So we're going to have to write that rate as a fraction to see what's going on with the units. So example 16, we got 20 miles or 200 miles divided by 50 miles per hour. So per is division, so per can be written as the divisor line. So really what this ends up becoming is 200 miles. And we can always write any number over 1. So since we're working with fractions, let's just turn that first quantity into a fraction. 200 miles over 1. And then we're going to divide by 50 miles on top. Per is the divisor line, hours on the bottom, 1 hour. Now we can convert this to multiplication. So division becomes multiplication, second fraction flips over. Now we've got matching units, miles. So we're going to cancel those. And the units we have left is hours. All right, so this is going to be 200 divided by 50 hours. And that's 4 hours. Note tray number 16. 300 gallons divided by 15 gallons per minute, GPM. All right, rewriting 15 gallons per minute as gallons over minutes. And we've got division now. Now we're going to convert to multiplication. And now we have matching units on top and the bottom. Gallons cancel, leaving us with 300 minutes on top, and 1 times 15 on the bottom. Units are all gone on the bottom, so we don't have any units there. Now we can do 300 divided by 15, that gives us 20. So the answer is 20 minutes. Our last one, your turn number 17. Let's divide 1,024 gigabytes divided by 64 gigabytes per second. So running 64 gigabytes per second as 64 gigabytes divided by seconds. We can now convert this to multiplication. So 1,024 gigabytes times 1 second over 64 gigabytes. All right, now the gigabytes cancel. Gigabytes are gone. Now we multiply straight across. 1,024 times 1 second, that's 1,024 seconds. Over, on the bottom, 1 times 64. So just 64, no units. And finally, dividing those number out, 1,024 divided by 64 gives us 16. And the remaining units are seconds. So 16 seconds. Now this technique, it takes a while to get used to. If it looks a little confusing at first, just keep at it, because we're going to be studying this technique throughout this entire unit. All right, ready? Have a great day.